In this exercise, we're asked to prove the following recurrence relationship. And the hint you get here is to start from the definition of the generating function and then taking the partial derivative with respect to x. So as usual, pause the video here and start cracking. So let's start from the definition of the generating function, because that was the hint we got. So exponential to the power x over 2 rather, t minus 1 over t. And we know that that's equal to the sum of n going from minus infinity to plus infinity, j n x t to the power of n. Right, so here we have our generating function. Next step is to take the derivative with respect to x. Why do we take the derivative with respect to x? Because we want to end up with terms like these. Otherwise, we will not be able to end up where we want to end up, right? So we take the derivative with respect to x. Doing that, some straightforward calculations, which hopefully I will not mess up. So we have 1 over 2 t minus 1 over t, and then exponential x over 2 t minus 1 over t. So that's the derivative of the left-hand side with respect to x. And then for the right-hand side, n minus infinity plus infinity j n prime of x t to the power of n. Next thing we're going to do is we're going to resubstitute the definition of the generating function in this exponential over here, because we know that this exponential, by virtue of this expression over here, is equal to this sum involving the Bessel functions. So let's do that substitution. 1 over 2 t minus 1 over t, and then we have a summation n going from minus infinity to plus infinity j n x t to the power of n again, and then we copy and paste the right hand side to bring us here. Before we move on, I do want to stress that the summation index n over here is very different from the summation index n over there. Here in this particular case, I am using the same summation index symbol because if you have them like this, it's no big deal. But when you really need to pay attention to having different summation indices is once you start looking at products of two series expansions. But in this case, that's not the case. So we can be a little bit more relaxed about the notation here. But be aware of the fact that these are actually different beasts. Now, if you're a bit familiar with this manipulation of series expansions, basically at this point in time, you can immediately read the solution over there. But let's go a bit slower here and give some intermediate steps. So the first thing we're going to do is we're going to expand that series expansion here. So that becomes 1 over 2 summation minus infinity to plus infinity j n x t to the power of n plus 1. And then we have a second summation with a minus sign actually, minus 1 over 2 summation j n x, and this time we have t to the power of n minus 1, and again the limits from minus infinity to plus infinity, and then finally on the right hand side minus infinity plus infinity j n prime x t to the power of n. Obviously, our goal will be to identify like powers of t such that we can recover the recurrence relationship. But in order to make that a little bit more straightforward, it would be easier if in each of these three series expansions we just had t to the power of n. And that's not exactly the case yet, but that's easy to fix. Here we just make the substitution n tilde equal to n plus 1. Which obviously means that n is equal to n tilde minus 1, right? So if we then massage our expression, we get the following. We get a summation of n tilde from minus infinity minus 1, but basically that doesn't matter, of course, to plus infinity. And then we have j n tilde minus 1, if we make the substitution. And then t to the power of n tilde. Okay, good. For the second series expansion, minus 1 over 2 here, what we're going to do is make a different substitution, which of course will be that n tilde will be equal to n minus 1. And again, remember that this n tilde is not the same as that n tilde. So n will be equal to n tilde plus 1. Okay, moving on. Summation again from minus infinity to plus infinity, j n tilde plus 1 x t to the power of n tilde. And then finally the right hand side, just copy paste, minus infinity plus infinity, j n prime x t to the power of n. Now in this case, we can easily identify the like powers of t, so that's pretty straightforward. Again, we just drop the tildes here because it's just a purely cosmetic operation at this stage. And if we do that, we can easily read that 1/2 j n minus 1 x minus 1/2 j n plus 1 of x is equal to j n prime of x. And that's almost exactly what we needed to show. You can just clean this up a little bit more. Just multiplying left-hand side and right-hand side by 2. But then we end up with the recurrence relationship that we needed to prove. Again, just by taking the derivative of the generating function with respect to x.